Hello students, now I am going to discuss how to draw a flowchart to check whether the given number is prime or not. Before starting this, you should know what are the conditions for a number to be prime number or not. Conditions are prime numbers or natural numbers that are divisible by 1 and the number itself. If you divide the number from 1 to that particular number, it should be divisible by only 1 and that particular number. Examples of prime numbers are 2, 3, 5, 7, 11, 13. All these numbers are divisible by 1 and the number itself. Now coming to the logic, how we have to implement this logic. First I am taking a number n and I am going to check whether this is divisible by 1 to n or not. N mod 1 equal to 0. Mod gives you the remainder value, right? If remainder is equal to 0, then it indicates the number is divisible by 1. Again, I am going to check n mod 2. I am going to check whether the given number n is divisible by 2 or not. Next, I am going to check whether the given number is divisible by 3 or not. Similarly, 4. This process repeats till n. So, if you observe, I am dividing n from 1 to n numbers and I am going to check the remainder. Let us consider this 1 to n as x. Right? I am taking one more variable x and this x is nothing but 1, 2, 3, 4 and up to n. For each time the x value is incremented by 1. X is equal to x plus 1. Right? And this continues till x is less than or equal to n, right? X value should be less than or equal to n till that particular time. This division operation or modulus operation should continue. Right? Let us take an example. I am taking n as 5. First, what I am going to do? I am going to check whether n is divisible by, that is 5 is divisible by 1. What is the remainder? 0, right? I got remainder as 0. Next, n mod 2 equal to 1, right? 5 mod 2, the remainder is 1. It's not a 0. Next, n mod 3 equal to 2. 5 mod 3 is nothing but the remainder is 2. It's not 0. n mod 4, 5 mod 4, the remainder is 1. Right? Next, 5 mod 5, the remainder is 0. Starting from 1, I checked x value up to n, right? X value should be less than or equal to n. Now, if you observe, division you are doing, the modulus operation you are doing, after doing the modulus operation, whatever reminders that you got, how many reminders you got? 2 reminders, right? So, let us make r equal to 1 for the first reminder. What is the second reminder? 5 mod 5 equal to 0. Increment the r value, that is 2. If r is 2, the remainder value is 2. That indicates that particular number is divisible by 1 and the number itself, right? 1 and the number itself. Then only you will get r value 2. Otherwise, you will get r value more than 2, indicating the remainders are more than 0. Okay? If r value is 2, it indicates the number is prime. Okay? Now, let us take one more example. N is equal to 4. First, what I am going to do? 4 mod 1. Remainder is 0. Right? Now I am taking r value is equal to 1. 4 mod 2. Remainder is 0. Right? Again I got 0. We have to increment the r value 2. Next, 4 mod 3. Remainder is 2. Should I increment the r value? No. I should not. Next, 4 mod 4. Remainder is 0. Should I increment the r value? Yes. You have to increment the r value whenever you get remainder 0. Right? What is the r value that you got? R value is 3. Is it less than 2 or greater than 2 or equal to 2? It is greater than 2. Right? Whenever it is not equal to 2, that is the r value is greater than 2, the number is not prime because it is divisible by 1, the number itself, and also it is divisible by other numbers. That's why we are getting more than 2. Okay, this is the logic behind the prime number and not a prime number. Okay, now let's go for the flowchart. I'm going to create a flowchart. Start. Every flowchart should start. Here, if you observe, should I read the n value? No. I have to check, right, whether the given number is prime or not. Okay. I'm going to enter the number. These two double quotes n. And the number value should be stored in variable n. Right? You entered the number. Next, what you have to do? We need x, right? X value you have to initialize. X value you have to initialize to 0. Next, what are the other variables that we need? We need R also, right? For calculating number of reminders. That value should also initialize with C. We have taken the inputs that are needed. First, n value to read the given number, x value to start iteration starting from 1 to n, R to count number of reminders that are equal to C. Now comes the logic. What is the logic that we are having? Whether the given number is n mod x equal to 0. Done. If n mod x is equal to 0, what should happen? Reminder equal to 0, what should happen? R value should be incremented by 1, right? R equal to R plus 1. Done. But before this, if you observe, x value, initially we have taken 0. X value should be incremented, right? And how many times it has to increment? If you observe diagram, x should be incremented by 1, right? X plus 1. Each and every iteration, x value should be incremented by 1. Now, if n mod x is not equal to 0, should I increment r? No, I should not increment r. And this process should repeat till x is less than or equal to n. So, I am taking a loop. Now I have to place these two inside the increment operation as well as decision operation. Right? And this loop should continue till x is, if you observe this particular loop, you are having no going up. No means the loop should continue till x less than or equal to n. So I have to take a opposite condition, x greater than n. If x is not greater than n, then this loop will continue. If x is greater than n, yes, this will terminate. Right? Done. Save. Let us save. Now this loop continues till x value is not greater than n. That is less than or equal to n. X value will increment. That incremented value will be compared to 0. If it is equal to 0, R value will be incremented. And again, X value is compared to 0. This loop will repeat. Right? Once this is done, next what we have to do? What is the next step? We have to check whether R is equal to 2 or not. Right? There is one more decision here. We completed X, we taken X and we incremented X by 1 till n. And we are dividing n to x and adding the r value 1 whenever the remainder is 0. Right? What is the final step? You have to check whether R is divisible, when R is equal to 2 or not. So I am going to take one more decision. Here, what is the condition that I am going to write? R equal to 2. If R equal to 2, what is the output? Number is prime. Prime number. N. I also want to display the number, that's why I am taking that. You can also copy and paste it. Here I am just editing not prime. If R is not equal to 2, that indicates R value is greater, so the number is not prime. Now I want to execute. See, immediately it is asking enter the number. Let us take the same example. Okay. X0, R0 loop starts. This particular loop is executed 5 times. You can check. Whenever it is divisible, the R value is printed. You can see number is prime because R value is only 2. Let us take one more example. Start, single click, enter the number 4. If I take 4 as n, the loop will be executed 4 times, right? Initially, x value is 0, R value is 0, going to loop. X value now 1, incrementing by 1. You can see here, x value is incremented by 1. Right? Now, 1 mod x equal to 0. Is it equal to 0? Yes. 4 mod x 1. 4 mod 1 equal to 0? Yes. R value will be incremented by 1. Now x value is 1. Right? You can see here, left side, x value is 1. 1 greater than n? No. Loop will go up. Right? Second time it's running. X value is again incremented to 4 mod 2. Is it equal to 0? Yes. So R value will be incremented. Now you can see R value is 2. Again, loop will continue. X value is incremented. X value is 3 here, right? Now, n mod 4, that is 3 mod 4 mod 3. Is it equal to 0? 4 mod 3? No. Right? Directly, without incrementing the R value, you got n. You are checking whether x is greater than n or not. Right? 3, is it greater than n? No. It should increment again. 4. Again, 4 mod 4. Yes. R value will be incremented. Now R value is 3. You can see you are getting 5. Is it equal to n mod greater than n? No. What happens now? X value is 5. You are checking for 5 also. Is it correct? Should we go up to 5? No. We should end at 4 only. So how I can change my condition to end at 4? Simple logic. Let us do this first. Double click. X value should be greater than n minus 1. Okay. Now let us read it. Start. N value I am taking 3. Okay. X value is 1. 3 mod 1, 0. R value is incremented. Is 1 greater than 3 minus 1? Yes. No. That's why the loop is continuing. X value is again incremented. Next, R value is not divisible, right? So R value is not incremented. X value is 2 greater than 2. No. You are getting it, right? X value is incremented to 3. Now the x value is 3. 3 greater than 2? Yes, 3 is greater than 2. That's why it's terminating that it is checking for R. Reminder. What is the R value that you got here? 2. Because 3 is divisible by 1 and 3 only. So S, the number is prime. You can see prime number 3. This is how you got the flowchart for prime number. And so many people are getting confused here for the conditions that you are taking. Please take the conditions x greater than n minus 1, x assigned to x plus 1, or x initialization with 1. You can take differently. Here I have taken x is equal to 0 initially. You can also take x is equal to 1. When I am taking x is equal to 1, do I need to increment it here itself? No. Right? I can increment it after performing the operation. Right? We can do like this. Now let's check our program. I'm giving the same 3. Okay. See, not prime 3. 3 is not prime. Is it correct? No. X value you got maximum 3 only, right? Had to execute up to 3, right? But where is the problem? Once you change this position, x is assigned to x plus 1. Here you have to change the condition. So x greater than n. Right? Now we can see. Okay? The number is prime. If you change the increment position of x to 0, then the condition should also be changed respectively. Okay? Because already first itself you are taking x is equal to 1. So one iteration you completed before itself. Right? One value you completed before itself. So no need to increment it before modules. You are doing increment after modules. When you are doing increment after modules, here x should be greater than n, not greater than n minus 1. Okay? You have to be careful about these iterations and where you are taking x increment. Okay? Hope you understood. If you have any further doubts, better you write all the iterations